Fantastic. Hi, I'm Ian, and as you said, I'm Microsoft, and I work on the Azure MAIA project. And today I want to talk to you a little bit about the work we've been doing on our team to support Azure MAIA with Triton. So the first slide you can see here is the Azure MAIA in a testing facility. You can see the sidekicks on one side, Azure MAIA, some networking equipment at the top, and the cooling conduits that go outside because, of course, the device is liquid cooled. Pretty cool. Drilling in, the MAIA 100 device architecture. MAIA is composed of 16 clusters, a control block, a security block, image decode, HBM, scratch pads, and networks on a chip. Drilling into the cluster, you can see that we have a control block, we have an L2 SRAM scratch pad, and we have 4 tiles and a network on chip again. And inside of the tile, which is something that the Triton developer on MAIA does not directly control, you see there's a DMA engine, L1 SRAM, a vector unit, and a tensor unit. We call the vector unit the TVP, and the tensor unit the TTU on the chip. So it's a fairly complex chip. It's highly asynchronous. We have a pool of hardware semaphores that we use to keep all of this asynchrony under control. And so the compiler has a ton of responsibilities in this area. So the first thing that the compiler really has to do is split the cluster work up among the 4 tiles I was talking about before and optimize its tile performance. So one of the first things that we decided to do when bringing Triton to Azure MAIA was we decided that we were going to bind the PID to a cluster on the device. And that was going to be the way that you were going to address your program IDs. And next, the compiler is completely in charge of injecting semaphores where they need to be injected and managing this pool of shared semaphores, this hardware pool. And finally, well, almost finally, data movement between all of the software scratch pads that I showed earlier is completely controlled, again, by the compiler. There is no hardware support for you here. These scratch pads are entirely controlled by software. So you can imagine it would be a huge source of bugs, and it's a huge source of inefficiency if a developer is having to manage this on their own. And we're getting some really good performance out of this. As you can see, this is very preliminary. And you have to trust me that on the y-axis, it's basically a measure of efficiency on the chip. Currently, for matmols, for Mistral 7B, our compiled kernels are meeting or exceeding the performance of most of the handwritten kernels implemented in our in-house C++ framework for MAIA, which is really, really cool and huge for the team. As a matter of fact, the team's here today, and I'd like to give you guys kudos for doing something so cool. And finally, a big thank you to everyone. We are hiring fully remote roles, both at the junior and senior levels. Send your CVs to triton@microsoft.com if you're interested in joining this team, which is showing some standout results. Thank you. And my friend Jonathan from AWS is up next.